Hey, what is going on, class? Welcome to Graphing Quadratics. For right now, we're going to start off with what I'm going to call the brute force method. Brute force. First thing in the morning. Brain's still got to catch up. The brute force method, or sledgehammer mathematics, as I prefer to call it, but I want you to know it's the same thing either way. That brute force tends to be how computer scientists or anyone who programs will think of it as being brute force, that you're taking and you're basically just bombarding something with methods of cracking it until it yields. And mathematically, I have always called this sledgehammer mathematics because you're taking very basic skills, things that every single one of you can do, and you can do it. You've made it here. You are capable. You can all plug in values to an equation. If you can't, come talk to me. We need to get that figured out because it's going to make your life a lot easier. The hard work is worth it. But you can all do that. You don't need to be a genius. You don't need to know any tricks. You just need to know how to make a table and plug in numbers. That's it. So what we're going to do is let's just start off with the equation. H of x equals x squared minus 2x minus 3. So all this video is going to be is putting numbers in. We're not going to do anything fancy. You're not going to try anything weird. All you're going to do every single time is make a table of xy values. And you're going to start off with a 2, 1, 0, negative 1, negative 2. Every single time. Until you figure this out, don't use the tricks. Every single time, you're going to start off by plugging in negative 2 through positive 2. And what we're going to do is we're going to take and we're going to plug this in. We're going to say that the h of 0 equals 0 squared minus 2 times 0 minus 3. Well, that becomes 0 minus 0 minus 3. Well, everything cancels out except for that negative 3. And this h of 0 is just saying your y value at x equals 0. This is a really handy notation because it takes and gives you instantly information that, hey, this negative 3 is a y value, and it happens when the x is 0. So then we come over here, fill that in, so we have negative 3. And now you're just going to plug in the other numbers. You should plug in every single one of those values to get a picture of what this thing looks like. So if we plug in 1, h of 1 equals 1 squared minus 2 times 1 minus 3, or 1 minus 2 minus 3. Well, this becomes negative 1 minus 3. We get negative 4. And then plug in your 2. So h of 2 equals 2 squared minus 2 times 2 minus 3. Well, that's 4 minus 3, or negative 3. Now, how many of you have confidence? You can do this. You can take these values and plug them in for x and square a number, multiply it by a number, and add and subtract a bunch of numbers. You can all do it. I believe in you. Believe in yourself. If you don't believe in yourself, there's no way you're ever going to learn this. Even if you can't, even if there's actually a limit of you can't do it. If you believe you can, you're going to be amazed. You might actually do it still. But let's just be disciplined. Let's just continue, plugging in our values here. Boy, oh boy. The one downside to this thing is if you don't write fast enough, it will erase what I'm doing. So when we're looking at this thing, we're now going to have -1 squared is really +1. Plus, we have a 2 minus 3. Well, what is 1 plus 2 minus 3? That's 0. And that's a very special number. That's a number we really like to see here, because that is 0. That means we have a y value of 0. And we like a y value of 0 because y equals 0 implies that x equals -1 is a root. That is super important to what we want here. In fact, it's so important that I'm regretting the way I wrote this. I'm going to have to take this and move it. I'm going to put it right there. Get rid of u. I'm going to make this go down like this. So that's a really important value. We really want that value. Now, let's just keep going. H of -2 equals -2 squared minus 2 times -2 minus 3. -2 squared is 4 plus 4 minus 3, or that is 5. Now, are we seeing anything that we want yet? And if you're not sure, graph it. So right now, if we draw in a little graph here, a little XY table, start graphing your XY points. So we have 0, -3, 1, 2, 3. We use different color just so we can see it clearly. And +1, -4. +2, -3. Then we have -1, -2. -1 is 0. And -2 is +5. 5. So we know what we want is something that looks like this. And we know kind of one of the requirements here that I've put on you is that's the wrong pen size. You must have 5 good points. And what it means to be a good point, one of those must be the vertex, 2 must be to the right, and 2 must be to the left. You have to be balanced here. Well, let's see. I've got a vertex because it's in the middle. I have 1 point on the right, and I have 3 points on the left. I'm a little skewed. So which point do I need to calculate? Hopefully you're sitting there like, okay, I need 1 more point over here somewhere. So let's plug in more values. Let's go over here because I need to go in the positive direction. Let's plug in a 3. So h of 3 equals 3 squared minus 2 times 3 minus 3. 3 squared is 9 minus 6 minus 3. Look at that. We got a nice value out. we got this 0, which means we have now found both roots. And those are convenient points to have because that means we got this nice curve here. So now you can come in and draw this. Now, I want you to think about, does this look quite right? Nope, it's not. So I'm going to take and move this thing down so I can make this thing look better. Because you should always have, when you're graphing a function, the edges of your function should get past, or at least even with, your axis. If you're just drawing something that looks like this, you did not graph the function. You graphed a very small amount of it because this thing goes on forever. But now we have that nice graph. And this right here is the brute force method where you just plug in values. And what you're looking for is you need 5 good points. You have to have, must be the vertex. You must have the vertex, 2 points to the right and 2 points to the left. So vertex, 2 points to the left, 2 points to the right. You have to have those 5 points. What you're looking for over here on the chart is you're looking for a value with the same numbers, or same number technically because it's one number, on either side. When you have that, so here we have a -4 that has 3's, or -3's, on both sides. And we can see from there that on either side, 2 away, it has a 0. And even further, we have a 5, which means over here at 4, this thing would be a 5 as well. That this thing is symmetrical about this point here that we call the axis of symmetry. So this is kind of our value with the same number on either side is called the axis of symmetry. Which from here on out, I will only ever refer to as the AOS. And that's what we're looking for here. That this value here, different color, let's go my bright green that I love. That we have this axis of symmetry here at 1, where if I were to graph a line here, this thing cuts it in half. Cuts it at that vertex where we have that point. The vertex is the only value that has this y value. Notice how everything else, there's 2 -3's, 2 0's, 2 5's. The vertex is the only one with this particular y value. And that's what makes it really special. So this is the method for those of you who are just starting off in graphing quadratics. This doesn't require a lot of you. This doesn't require you to understand much. This just requires you to go, okay, table, -2, -1, 0, 1, 2. Plug those values in to the equation. From there, kind of plot a graph and see, okay, do I have this reflection point where I have this -4 and then I have the -3's on both sides? This could be any numbers, but as long as you have a number with the same number to the left and the right, then you found it, and then you just need to have 2 values above that thing and 2 values below it. So be sure to come in if you have any questions. I would love to help you on this stuff as well. There will be videos coming out here soon looking at the easy ways to graph this, kind of the shortcuts. But make sure that you understand this process first, because the shortcuts aren't going to mean anything to you unless you understand how to just plug values in and use the equation for things that you don't know how to do. If you have any questions, please come in. I would love to help you. You have a quiz coming up soon, and then you're going to have a test soon. So I will talk to you later.